Welcome back to the Autonomous Vehicle Guidance series. Today's focus is a classical and widely used guidance strategy called the pure pursuit, adapted to 3D space for aerial and autonomous systems. Imagine you're guiding a drone to follow a predefined spatial trajectory like a helix. In such cases, we need a controller that can continuously calculate a target direction in space and adapt as the vehicle moves. Pure pursuit is a geometrical guidance law. Rather than following a fixed waypoint, it locks onto look-ahead point a fixed distance ahead along the path. The vehicle then steers towards this moving look-ahead point, effectively chasing the trajectory. In 3D, pure pursuit becomes more complex. We need to calculate the closest point on the path to the drone, then advance the fixed arc length to define the look-ahead point. Then, we compute a unit direction vector from the current position to this target and apply a steering force in that direction. We assume a simplified vehicle model Newtonian kinematics with acceleration aligned along this desired direction. This model works well for drones where attitude control is assumed fast and decoupled from position control. The trajectory we'll follow is a 3D helix. We initialize the drone off path and apply the pure pursuit algorithm in a loop. Find the closest point on the path, calculate a look-ahead point ahead of it, steer towards the look-ahead point. As the drone flies, you'll see it adjust its course in 3D, gradually locking on and following the trajectory. This guidance law is robust, computationally light, and easy to implement in embedded systems for aerial robotics. If you found this helpful, be sure to like, subscribe, and hit the bell so you don't miss future lessons. Thanks for watching and see you in the next video.